हेलो एवरीवन, वेलकम टू माय क्लास। आज हम 10वीं क्लास का चैप्टर 1 रियल नंबर्स का सेकंड क्लास स्टार्ट करने जा रहे हैं, जो कि फंडामेंटल थ्योरम ऑफ अरिथमेटिक्स पर होने वाला है। तो आज का टॉपिक है फंडामेंटल थ्योरम ऑफ अरिथमेटिक। तो इस थ्योरम की स्टेटमेंट जानने से पहले हम कुछ बेसिक चीज़ें जान लेते हैं, जिसके बारे में पता ही है। वो है एक प्राइम नंबर, और दूसरा है हमारा कंपोजिट नंबर। प्राइम नंबर वो नंबर होते हैं जो सिर्फ एक से और अपने आप से डिवाइड होते हैं, जैसे 2, 3, 5, 7, 11, 13 etc। एंड कंपोजिट नंबर वो नंबर होते हैं जो नंबर प्राइम नंबर नहीं होते, दैट इज 4, 9, 6, 8, 10। These are not prime numbers, right? So that is why they call composite number. Prime number, the numbers which are divisible by 1 and itself except 1. For example, 2, 3, 5, 7, 11, 13 etc। ये वो नंबर है जो एक से और सिर्फ अपने आप से डिवाइड होते हैं। इन नंबर को प्राइम नंबर कहा गया है और अभाज्य संख्या। दूसरा कंपोजिट नंबर, वह नंबर जो प्राइम नंबर नहीं है, मीन्स नॉन प्राइम नंबर्स आर कॉल्ड कंपोजिट नंबर। फॉर एग्जाम्पल 4, 6, 8, 9, 10 etc. are example of the non-prime numbers. You can check. 4 can be divisible by 1, 2 and itself. But as per definition of prime numbers, it's contradict the fact of definition. So that is why 4 is not composite. No, sorry. That is why 4 is not prime number. It is composite number. So now come to the statement of fundamental theorem of arithmetic. ये फंडामेंटल थ्योरम ऑफ अरिथमेटिक हमारे लिए इम्पोर्टेंट भी है, क्योंकि ये बताता है किसी भी कंपोजिट नंबर को हम उसको प्रोडक्ट ऑफ प्राइम नंबर्स के फॉर्म में लिख सकते हैं। मीन्स 4 can be written as 2 into 2, and 2 is prime number, so this is the product of two prime numbers, and 4 is composite number. Similarly, 18 can be written as 2 into 3 into 3, and these numbers are prime number. So statement of fundamental theorem of arithmetic is that every composite number can be factorized as a product of prime numbers, and this factorization is unique a part in which the prime factor occurs. So here the statement: every composite number can be factorized as a product of prime numbers and this factorization is unique apart in which the prime factorization occur. That is, this factorization is unique and this composite number can be written as a product of prime numbers. Now, इन फर्स्ट क्लास हमने एचसीएफ के बेस पर कुछ प्रॉब्लम सॉल्व की थी। यूक्लिड डिवीजन लेमा का यूज़ करते हुए हमने कुछ नंबरों का एचसीएफ निकाला था। अब बेसिकली वो एचसीएफ होता क्या है उसके बारे में देखेंगे। एचसीएफ इट्स अ हायर कॉमन फैक्टर but its proper definition is product of smallest power of common prime factors of the numbers. Second is LCM. Here is highest, here this one is least common multiple. Product of greatest power of each. For LCM, we are taking each numbers, and for SCF, we are taking only common numbers, common prime factors, and here is each prime factors. Each prime factors of the numbers. So there is only one difference between SCF and LCM, that is here is a word common, and in LCM there is a each prime factors we are considering. So we have general formula for SCF and LCF, that is given any two number we can find the SCF and LCF. SCF and LCM and their product is also equals to product of given two numbers. That is, let A and B be any positive integer, then their SCF A comma B into product LCM of A comma B equals to product of A into B. So this is a formula of given two number, and HCF and LCM of those two number will be also equals to the product of those two numbers. So if this is the theoretical part of the section 1.2. इसके बाद इसकी एप्लीकेशन के लिए हम इसके एक्सरसाइज के क्वेश्चन सॉल्व करेंगे. So here's the first question. Express each number as a product of its prime factors. तो 5 ऑप्शन देखे हैं, 5 पार्ट है हमारे पास, इन सभी को इनके प्राइम प्रोडक्ट में हमें लिखना है और फैक्टराइज करना है इनको। फर्स्ट पार्ट ट्राई करते हैं। 140 को हमें प्राइम फैक्टर के प्रोडक्ट में लिखना है बाय सिंपल डिवीजन मेथड। 140 can be divided by 2 gives 70. It also can be divided by 2 gives 35. 35 divisible by 5 gives 7, and this one gives 1. So 140 can be written as 2 into 2 into 5 into 7, which can be also written as 2, and there is a twice 2, that's mean 2 square into 5 into 7. That is our answer. 140 can be written as a product of two prime numbers, which can product of three prime numbers, which can be written as this. Now come to the third part. 3825. 3825. So this can be divided by 3. 3 and 8, 11. 11 or 12, 13. 13 and 5, 18, which is divisible by 3. 3. So this gives us 1, 2, 7, 5, which can be also divisible by 3. 3 and 7, 10. 10 and 5, 15, which gives 4, 2, 5, and this is divisible by 5, gives 85. 85 is divisible by 5 on 17. 17 is prime number, therefore we have 3825 equals to 3 into 3 into 5, 5 into 17, which can be written as 3 square 5 square into 17 raised to power 1. This method, also called prime factorization method. Fundamental theorem of arithmetic, it said any composite number can be written as a product of prime numbers, and this is found out by prime factorization method. So this method is prime factorization method. This method called prime factorization method. ओके, बाकी पार्ट आपके होमवर्क के लिए है। क्वेश्चन 2, find the LCM and HCF of the following pairs of integers and verify that LCM multiply HCF equals to product of the two numbers. So let's take second part. जो हमने फॉर्मूला लास्ट में हमने किया था, दिस वन, इस फॉर्मूले को हमें वेरीफाई करना है सेकंड क्वेश्चन में। सॉल्यूशन, सेकंड पार्ट 510 and 92 by prime factorization. 510 divided by 2 255 divided by 551. 17, and here's 92. 46, this can be divided by 2. 23, and 23 is prime number, so gives 1. Therefore 510 equals to 2 into 3 into 5 into 17, and 92 equals to 2 into 2 into 23. और हमें इस क्वेश्चन में एचसीएफ और एलसीएफ दोनों फाइंड करना है. Therefore एचसीएफ क्या होता है हमारा? प्रोडक्ट ऑफ स्मॉलेस्ट पावर ऑफ कॉमन प्राइम नंबर. और स्मॉलेस्ट पावर ऑफ कॉमन प्राइम नंबर कितने हैं हमारे पास? सिर्फ ये पेयर है. मीन्स एचसीएफ कितना हो गया इन नंबर के लिए? 2. एलसीएम प्रोडक्ट ऑफ ग्रेटेस्ट पावर ऑफ ईच प्राइम नंबर. ग्रेटेस्ट पावर ऑफ ईच प्राइम नंबर कितनी है? 2 की हाईएस्ट पावर कितनी है? 2. दैट इज 2 स्क्वायर इंटू 3 5 into 17 into 23, which is equals to 4 into 15 into 17 into 23. So we can multiply these two numbers, which gives 23460 after multiply these four numbers. Okay. अब वेरीफाई करना है हमें एलसीएम इंटू एचसीएफ इक्वल्स टू प्रोडक्ट ऑफ टू नंबर्स. नाउ एचसीएफ of a comma b into LCM of a comma b equals to a into b. Therefore consider left hand side, which is HCF times LCM, which is equals to HCF is 2 and LCM is 23460, which is 02964, and RHS, which is right hand side, that is 510 multiply 92, which gives 234 sorry 46920. Therefore left hand side equals to right hand side, hence verified. You can verify this product by multiplying these two numbers. Verified. Question number 3 and 4 is similar to question number first and second, so we can do it easily. So mark it homework. And now come to the question number 5. check whether 6 raised to power n can end with the digit 0 for any natural number. क्या 6 की पावर अगर n n मीन्स कोई भी पॉजिटिव इंटीजर अगर हम लेते हैं तो क्या उसके लास्ट यानी कि यूनिट डिजिट जो होगी वो 0 हो सकती है? मीन्स for n equals to 2, 6 raised to power 2 gives 36, right? For n equals to 3, 6 raised to power 3, 36 into 6, that is 6 square into 6 we can write. So this also not gives unit place is 0. So we need to show that is not possible. Solution, maybe for any number, if any number ends with the digit 0, that number can be divisible by 2, 5 and 10 as well. So if any number ends with the digit 0, for example 120, 360, 480, these numbers ending with 0, so these numbers can be divided by either 2, 5 and 10 or all. Can be divided by 2, 5 and 10. Since 10 can be written as the product of these two numbers, 2 into 5, right? Therefore, prime factorization of 6 raised to power n equals to 2 into 3 whole power n, right? From this form, can we say 5 is a not in this prime factorization? Yes, but 5 is not in the prime factorization of 6 raised to power n. Therefore, if 5 is not in the prime factorization of 6 raised to power n, then 5 cannot divide this number. Therefore, for any value of n, 6 raised to power n will be not divisible by 5. Therefore, 6 raised to power n cannot end with the digit 0. For any natural number n. बाकी बच्चों के क्वेश्चन mark it homework, and thank you for today class. We will meet tomorrow.